indicators today. When we measure, there's different ways of measuring pH. We can, for example, we could use a pH meter. Pretty accurate, usually 5.1. You can get down to the nearest decimal. They're probably even more accurate than that, obviously, if they're calibrated correctly. We can also use pH paper like we did last day, which is a pretty good, still pretty good indication. You can get it down to 5, maybe 5.5. You could kind of guess colors in between on that pH scale there, kind of thing. You could get 8 or 8.5 or 9, probably. Anything more specific than that would be tough. And finally, there's another way we can do that is through indicators. And indicators are probably the most generic type. However, you'll talk a little bit about indicators next year as well and how they're made. They're quite complex compounds, I guess you could say. And basically, they help you kind of narrow down the pH range. So today, your job is not going to be, hey, this is going to be a pH of 3 or a pH of 2. That you can't do that today. What you can do is say, hey, today's pH for this solution that we have is going to be between 2 and 4, for example. That's the best you're going to be able to do. Or perhaps 3.8 to 4.6 kind of thing is the best you're going to be able to do. So you're going to be able to narrow it down, but that's the best you're going to be able to do. You can't get a specific value today. I don't want to see any numbers like, hey, I think it's 5.8, because it's not, okay? It's got to be somewhere, it's a range, okay? So they have the ability to change color depending on the pH of the solution into which they are placed. Here's a chart. Here's about 11 indicators that we will use. Actually, you're not going to use all these indicators today, but here is some examples of indicators, okay? And basically the pH range that they measure. Now, here's what's important about this, so pay attention, please. Let's say, for example, we use this methyl orange one here. Well, methyl orange has a pH range of 3.2 to 4.4, and in that range of 3.2 to 4.4, it changes from, of course, we see red to yellow, okay? What that basically means is this. If the pH was 3.2 and lower, we would see a red color. So anything lower than 3.2 would be a red color. So if, let's say, the solution was a pH of 1, if I put some methyl orange into there, you would see a red color, okay? If it was 4.4 or higher, I'd expect to see a yellow color. This would be your yellow color there, okay? And if it was actually in between those two, 3.2 to 4.4, let's say the pH was 4, you'd expect a combination of red and yellow, which of course is purple. No, orange. Primary colors, people, come on. So orange would be a primary of the mixture of those two. So if the pH was actually in between those, you'd probably see an orangish color, okay? And I'm going to give you some examples on what to expect with this. This one here, they actually tell you here, in case you don't know. This is yellow here, so anything at 6.0 and below is yellow. Anything at 7.6 and above happens to be blue. And the mixture of yellow and blue, if you had both, of course, yellow and blue would be, of course, a greenish color. So that would be in between these two. Anywhere from 6.0 to 7.6, you'd probably see a green. And you might say, well, would I see different shades of green? And the answer is, yeah, probably, okay? What exactly number does that correlate to? Don't know, okay? All I could tell you is that it's between those two, all right? In phenolphthalein, for example, okay, 8.2 and below, if you had a pH of 7, for example, you would see nothing. You would see a clear solution still. If the pH happened to be 10 or above, you'd see a pink color. What's the color in between those two? Well, what's between clear and pink? And the answer is light pink. Yeah, light pink. And that's actually going to be a lab that we're going to do later down the road here. We're going to look for that light pink color, okay? Not today. And so on and so on. So let's take a look at some of these examples here. So we're going to have, basically, I gave you 2 sheets today, so this is what we're doing here on the second one. You're going to hand this in to me at the end of class today here. On the second one, you'll see you have 6 unknown solutions across the top. Each one of those has a different pH, okay? So the only difference is I call them A, B, C, D, E, F, and you have 1, 2, 3, 4, 5, 6. So figure that out for yourself, all right? You're going to use those 5 indicators there to help you narrow down the pH range. So, and I'll give you an example of what you're going to see here, kind of like this. Now, this is not from that sheet there, of course. These are just independent examples here. But if we look at the first one here, it says a solution of unknown pH is tested with phenol red. So phenol red, okay, phenol red, and it remains a red color. So this phenol red has a red color to it. Let's take a look at phenol red here. Where's phenol red? Right here. Okay, so phenol red's here, and it stays red. Okay, so this would be the red one here, and this would be the yellow here. So what can you deduce from that? If you put phenol red into this solution and it stays red, well, it's 8.0 or higher, right? That's all you can say. So this didn't really narrow it down at all, did it? 8.0 and higher. I guess it eliminated about half of the pH range, okay? And that's all you would put for that right there, okay? And you'd be done, all right? The second one here, okay, you're going to test it with methyl orange and bromothymol blue. So methyl orange and bromothymol blue, and both of these, of course, appear yellow, it says here. This is a different solution, by the way, just another different example here. So let's take a look at what does methyl orange with a yellow color mean. So methyl orange, find that on your sheet here, guys, methyl orange, third one down, and it's got a yellow color. Yellow corresponds to that 4.4 number, yes? So all I can tell you is that it's 4.4, oops, and above, yes? Okay, find that on your sheet and look at it. Once again, here's methyl orange here, right? 4.4 and above. So that's all I can tell you is that if it's yellow, it's got to be 4.4 and above. That's all I know from that, okay? But look, if we use two indicators, okay, bromothymol blue, for example, as also in the same solution, or testing part of that same solution, I get a yellow color again, and I see yellow corresponds with this 6.0 and below, okay? So once again, bromothymol blue's right here, okay, bromothymol blue. Here's the yellow, 6.0 and below, right? So it's got to be that way, right? Below 6.0. So what can you basically deduct from that? Well, I would say that the pH range, of course, is 4.4 to 6.0. Okay? It's got to be somewhere between there. So just by using two indicators, sometimes you can narrow it down quite a bit. Yes? Okay? Yep. Yep. Yellow is the lowest, green is the middle part in between the two numbers, and then blue is the highest part. Okay? This one here, we tested with methyl orange. So methyl orange, orange 4, I believe, phenol red, and methyl red. And all of these appear yellow, of course. So all these are yellow. So what does that mean for each one of these? Well, we got to go back through here. Methyl orange, if it's yellow, is 4.4 and above. Okay? Orange 4, if it's yellow, 2.8 and above. If phenol red is yellow, we're looking at 6.6 and below. Okay? And finally, methyl red, if it's yellow, it's got to be 6.0 and above. Okay? So, what's the narrowest pH range for these four here? Where can we narrow it down to? Yeah, so we're going to go from 6.0 to 6.6, right? And that would be our narrowest pH range, right? So you might say, well, okay, what's the purpose of this one here? Well, you know, once again, you're going to have these same things today. What's the purpose of using 5? It's to narrow it down the best you can. If nothing else, it confirms the fact that, hey, whatever solution we have, okay, let's say it's 6.3, just for an example. Hey, is it above 2.8? Yep. Is it above 4.4? Yep. Is it above 6? Yep. Is it below 6.6? Yep. It's in that range, right? 6.0 to 6.6. So we know that these two here, these two top ones here, are basically just confirming, you know, those two confirm, well, the bottom one, really, okay? Do I need to use all four indicators? And the answer is probably not. How do you know, though? You got to start somewhere, right? How do I know to pick phenol red and methyl red just to start right from the beginning? For example, when we walk into the lab and you say, hey, I'm going to test these 6 solutions, maybe I'll just pick those two. Well, you'd be incredibly lucky. Okay, you got to start somewhere, so you got to start testing each one of these indicators, writing down the numbers. So I want to see this, I want to see the color, yellow, and then I want to see the meaning of it in each one of these squares here. Okay, what does it mean? Well, it means 4.4 and above. Okay, you're going to do that for all of them, and then at the end, you're going to narrow it down to the best possible options, okay, or the lowest possible range that you can get for that. Okay, is there any questions on that? Yes or no? Yeah? Okay, there's a little bit more to it when we get to the lab, but it's pretty much that straightforward. I'll show you exactly how to do this, but it's pretty much that. All right? And that's the end of this unit here for today. Well.